I already had the opportunity to speak to INSEAD alumni 2 or 3 years ago, and I was impressed by the quality of the debate. For the conference today, you received two documents. The first one is an article on the energy transition I published in a specialized media, La Revue de l'Énergie, and the second one is a report from a working group I chaired last year. I will start by setting the scene on energy transition, and then I will focus on one important challenge of this energy transition is how to ensure the security of supply of electricity and avoid blackouts. So I will start by setting up the scene, and the title of my article is Energy Transition Between Political Injunction and Lack of Prospective Approach. I was amazed to consider that there is a total lack of prospective approach in the decisions which are taken days after days on energy transition. So energy transition is becoming year after year a major political theme. The environment dimension of climate change is predominant in the debates. Often it is summarized by a simple phrase, save the planet or carbon neutrality by 2050. We use to refer to climate urgency. And as a result, stakeholders are investing in a hurry in inefficient and expensive solutions and don't take the time to analyze rigorously the constraints, both technical, economic, social, or geopolitical. They set up ambitious goals, but these goals don't make sense without a rigorous action plan considering the various constraints. When it appears that these ambitious goals will not be met, then the goals are strengthened, so we enter in a vicious cycle. When you put the target too high, you are sure to miss it. So it is mandatory to take the prospective approach, highlighting the key dimensions and the long-term trends in order to determine the evolutions which are preferable and those which are unreliable or hazardous. So what are the key determinants of energy transition? It's mandatory to approach the energy transition in the general framework of sustainable development. This concept has been defined in a report to the United Nations in 1987 by Gro Harlem Brundtland, at that time Prime Minister of Norway. Sustainable development includes three dimensions inseparable: economy, social, and environment. And too often, the two first dimensions are understated, and we refer to sustainable development, we only refer to the environment dimension. Technologies may be available, but is there a business model? Who will invest? Who will pay? How to ensure these technologies will be socially acceptable? Just consider the increasing opposition to wind farms. And you know the concept of NIMBY, not in my backyard, or banana, build absolutely nothing anywhere near anybody. We need also to take into consideration the inertia of the energy system. For example, the turnover of the residential sector is around 1% per annum. Power plants are built for at least 50 years. The inertia is highlighted by the projections of the International Energy Agency and in its stated policy scenario report in the World Energy Outlook 2020 report, fossil fuel still represents 72% of the energy mix in 2040, compared to 80% in 2019, despite all the policies and measures decided and put in place. There is also a direct correlation between energy consumption and economic growth. The increase of the world population and the living standards imply a growth of energy demand. According to the IEA, again, even if energy demand will decrease a little bit in the mature economies, it will still increase by 38% in the rest of the world. We should not ignore also the geopolitical dimension of energy. This is obvious for oil and gas, but it's also the case for renewable energy. The technologies of energy transition are relying on resources located in a small number of countries. For example, China for rare earths, PV, or batteries. The present pandemic is obviously a major game changer. Its impact on the energy sector has been huge in 2020, but it's very difficult to anticipate the long-term consequences of this pandemic. In the debate on energy transition, silver bullet solutions are flourishing, and we should avoid false solutions. It's mandatory to avoid any confusion between technologies at a very low maturity and those with a business model which can be deployed and where the stakeholders may invest profitably. Just take a few examples. For many decades, nuclear fusion has been presented as an inexhaustible and non-polluting energy source. However, we are still very far from development. Only few improvements have been made during the last decades. A pilot is under construction, ITER, but the technical feasibility is not ensured today, and the economical profitability of this energy source is far from certain. Direct capture of CO2 in the air is often presented as a breakthrough. It is technologically feasible, but the CO2 concentration in the atmosphere is very low, 400 parts per million ppm, compared to around 20% in the fumes of a thermal power plant. So energy consumptions and cost are enormous. We should also consider the fashion mode of these silver bullets. Different technologies have experienced media uproar. It was the case of hydrogen after the first oil shock, electric vehicle in 1990s, biofuels during the last decade. We should learn the lessons from this past experience and consider seriously how these technologies may be developed now in the present circumstances. So to conclude I would like to conclude my introduction by highlighting the main paths in 10 silver bullets. First, one certainty, the share of electricity in the energy mix will increase. So it's a huge mistake to ignore two major technologies, nuclear energy and CO2 capture and storage. Second, energy efficiency is obviously a no-regret strategy. Third, renewable energy will play an increasing role, for example, wind and solar. But we should not forget other renewable energy sources, such as hydroelectricity or biomass. The growth of wind and solar electricity, which are intermittent and non-dispatchable, are creating a risk of blackout in almost every country in the world. And I will develop this specific point in my following presentation. Renovation in the residential sector is mandatory. However, we should not ignore the rebound effect, which is jeopardizing the impact of huge investments in renovation. 6, some technologies are available to reduce the impact of the transport sector, but it is necessary to get a systemic approach linking the urban development and the demand for mobility. 7, energy transition will be expensive. It is mandatory to calculate the cost, both in CapEx and OpEx, of the different technologies in order to favor the most efficient ones. And unfortunately, the policymakers, they refer to technologies, but they don't calculate the cost of implementing these technologies. Next, the Kyoto Protocol in 1997 recommended to implement in parallel mitigation measures, but also adaptation measures. And unfortunately, adaptation measures were almost ignored. We should not forget also the Kyoto mechanism put in place in order to mobilize funds in favor of developing economies and in order to invest where it is the most, when the return on investment is the highest. New technologies are needed. This is requiring to increase the R&D funding worldwide. And last but not least, we need to ensure the acceptance of population on technologies put in place and also on the related costs. So that is my introduction, and I may, if you agree, make a focus, but perhaps I may ask some questions before I move to my presentation on power system flexibility. Venkat, it's up to you.
If there are any questions, please go ahead. We have around 40 people so that we can make it. I just give it 5 seconds pause if there are. Right, let's go ahead with the next set of. Yeah.
Okay, so you received the report which has been made in a working group I chaired last year. And what is clear is that the security of electric power system is really a highly topical issue. I just want to remind you the major blackouts in California in August 2020, or more recently in Texas in mid-February. The European network was subject to strong tensions last year following a problem of interconnection between Austria and Germany. The power was cut in London for several hours on the 10th of August 2019, and the European grid was put under pressure regarding security of supply last 8th of January, following a technical incident in Croatia that split the European synchronous grid in 2 parts. And the French TSO was obliged at the time to take measures to manage industrial demand response and also issued a recommendation to the general public in order to limit their consumption. So this is really a topical issue, and it was the subject of the report made in a working group of INRT. INRT is an association, National Association of Research and Technology. It gathers numeric public and private research entities, and you have on this slide the name of the entities with which participated to this working group. What is the theme? What was the theme of this working group? It is to describe the main challenges and present power system flexibility solutions by analyzing their potential and conditions required to produce and implement them for France and its European environment. So we use some words, some technical word, and on this slide, you have a glossary in order to explain the acronyms which are used. I remind you the plan of the report. The first part on the definition of the flexibility requirement, then the different deadlines. Afterwards, third part, what flexibility solution exists and what are the conditions for implementing them. As INRT is an entity focused on R&D, then we present the R&D priorities identified by the working group, and then recommendation to the different stakeholders in order to implement these priorities. So what is the definition of flexibility? Flexibility is the measures which are requested in order to avoid a blackout. So the definition of flexibility is the intentional adjustment of power during a given period in response to a signal. And the power system has to balance supply and demand in real time, taking into account the fact that electricity storage is difficult, especially on a large scale. The grid has been constructed with a bottom-down approach, with top-down approach, sorry. Electricity is produced by large thermal or nuclear power stations and delivered to consumers through a high-tension distribution network. This makes it possible to deal with variable supply and demand over time, summer, winter, day, night. But the electric power system has been subject to considerable changes over the last 20 years, following major shifts in policy, economics, and environment and regulation. The electricity mix is developing fast with a move towards renewable energy. But renewable energy is intermittent by nature, as does not have the inertia of thermal and nuclear power station. Fewer machines running in the system can generate a drop in frequency and voltage and lead to significant supply-demand imbalance, triggering power cuts. Another factor is that grids are being decentralized more and more with a sharp rise in self-consumption, creating new balances issues at in the grid at the local level, which DSO, distribution system operators, have to deal with. This involves the mobilization of all sites connected to the grid if they are in the right place and available at the right time. So this new situation involves greater flexibility requirements at every level. In its World Energy Report, the International Energy Agency underlined that every country in the world is facing an increasing challenge of flexibility. According to the IEA, flexibility demand is growing twice as fast as electricity demand. Consequently, the doubling of electricity flexibility requirements by 2040 will be a major challenge in Europe and around the world. Flexibility in electric power system will be crucial to maintain reliable electricity supply, which justifies investment in different means. Our reflection is considering different deadlines. In the short term, and short term is almost tomorrow, flexibility needs on the European grid are going to grow with the decommissioning of 22 gigawatts of nuclear and coal-fired power stations in Germany by 2023. Another 6 gigawatts of nuclear power stations are due to close by 2025 in Belgium, along with 21 gigawatts of coal-fired stations in France, the UK, Spain, and Italy. This is representing about half of the production capacity in France. The next energy plan in 2023, the PPE, what we call PPE, will have to include these new constraints. This reflection consider objectives to reduce CO2 emission by 2030, as well as decisions to be made regarding nuclear power in France by 2035 and national low carbon plan by 2050. So network flexibility is initially ensured by controlling power at both supply and demand levels. The next stage of flexibility involves supporting the network during periods of tension. It is known as grid support. Lastly, the loss in network inertia due to the reduced share of thermal power stations can be compensated by introducing artificial inertia, which is called grid forming. In this condition, flexibility solutions start with power adjustment, interconnections, storage technology, and demand response management. So what are the flexibility solutions? First, adjustment of conventional production has been employed since the grid began, but as a basic response. This is therefore a strong contender for renewable energy integration, even though the resulting load following represent a significant loss earning, for example, for nuclear. Interconnection are another solution for flexibility in Europe. In fact, renewable energy fluctuation can be partly compensated by load balancing between one country and another country. This need for interconnection exists between European countries, but also within each country, along between the north or the south of France, for example. Along with the high cost of these high tension, high voltage lines, local acceptance is an issue. For example, Germany has a considerable need to connect wind turbines in the North Sea to factories in the south of the country. But by 2019, it had only succeeded in setting up 36 kilometers of high voltage lines. Another challenge is the fact that there may be periods of cold and anticyclonic weather all around Europe, and so there can be compensation through interconnections. Storage technologies are characterized by the following parameters: energy capacity, charge and discharge time, conversion yields, cost, and environmental impact. The potential technologies are also at different maturity stage. For storage of large quantities over long periods, the obvious solution is pump energy transfer station. However, they have limited development potential in Europe. Domestic hot water tanks also contribute to flexibility. The lower cost of lithium-ion batteries make them a solution to compensate the fluctuation of renewable energy or maintain frequency. But the storage capacity is limited to a few hours. However, some solutions exist for longer-term storage: flywheel, redox battery, compressed air in cavern, hydrogen. But in fact, this technology is still very immature. Their cost is high and no business model exists to date, given that price signals on the market are too short-term and too partial to provide an incentive. Capacity mechanism has been put in place, aiming at making up at least part of the lack of long-term signal. Demand response is playing a major role. It has been developed at the industrial level in Europe. In France, 2.5 gigawatts were used in 2020. The potential could be doubled, but that would require costly investment from the industry and also to adapt the design of industrial tools. It was what we call flexible design. Domestically, hot water tanks are the primary means of managing demand response for private individuals. In France, the power of this apparatus represents 15 to 20 gigawatts. Demand response management could be taken further by drawing up a contract between the operator and the final customer to allow remote control of the consumption of apparatus that have flexible loads and can be controlled at a distance. For example, heating pumps, heating, and in the near future, electric vehicle via the technology of vehicle to grid. This would make it possible to avoid producing electricity at peak times. The digital revolution offers new possibilities in that sense, although once again, involving only short-term demand response. So, wait. So, excuse me, I missed a point. What are the conditions to be put in place in order to implement these technologies? The performances of this mechanism will be highly dependent on the spatial and temporal scales that they are implemented on. From a special point of view, the main challenge is to interface the services provided from an individual and domestic level right up to the European grid. Concerning time scale, flexibility will need to interface almost real-time mechanisms with decisions whose impact will span decades. The energy transition will involve considerable investment. This investment will depend on decisions made by increasingly numerous and decentralized actors. The current market mechanisms put in place in Europe are strongly oriented towards short-term decisions. How can long-term investment be financed given this situation? While initiatives put in place by public authorities are starting to be visible, I referred, for example, to capacity mechanism, their long-term effectiveness remains to be proven. Multi-annual contracting measures should be developed. The issue remains of sizing the production fleet and the grid, with the objective being to strike a balance between the cost of building peak load capacities and the loss for the community associated with a failure in the system. The tarification should above all reflect the costs. In other words, integrate all service provided by the electric power system. In an increasingly flexible system, the price of electricity should take into account the value of the flexibility and remunerate the service provided to the system. Yet, the cost of accessing the grid depends above all on the power guaranteed and not on the energy withdrawn. Currently, the pricing structure is based on an energy power ratio of about 80 to 20%. Reflection will be needed regarding the energy power balance according to the type of use and the price electricity of the power withdrawn for these users. For all these issues, once again, digital technology can provide solutions. Caution is crucial in terms of cyber security and also the risk of foreign operator capturing values through digital. So now, what are the research needs and priorities? Our work has identified requirements and priorities in terms of R&D. The first priority is related to digitalization of the system. Digital technologies provide system stakeholders with a capacity to better anticipate, control, or flexibility in real time. Decentralizing control and dispatch involves deploying sensors, software, and interfaces from methods resulting from analyzing data and artificial intelligence. It's important not to ignore the intellectual property rights issues and the risk of foreign players capturing value. The increasing digitalization of the system also calls for caution in terms of cybersecurity and cyber criminality, as I said before. Secondly, it's imperative to maintain modulation of electricity production. This concerns both future controllable power stations, in particular nuclear, and the injection of curtailment of renewable energy. It will require deploying power electronics equipment for grid forming. Reinforcing interconnection will be vital. Underground lines are possible. It's the HVDC technology, but only if the cost can be brought down. Storage technology are a major issue, as I said. For the short-term storage, R&D should put priority focus on improving the manufacturing process of batteries, new concept, and optimizing the vehicle-to-grid concept. Work on interseasonal storage is at a less mature level. Realistic business models need to be founded by developing demonstrators. Sorry. Concerning demand response, priority should be injection and cutting conditions and control of the associated power electronic. The development, the development of flexible, reliable network will require overcoming technical obstacles such as systemic integration of already mature solutions in information technologies and communication. For example, the development of mixed AC-DC architecture, the creation of artificial inertia, synchronous condensers, and so on. New business model will be needed along with the framework of developing concrete solutions. The increasing complexity of the grid requires modeling at different spatial and temporal scales in order to optimize decisions made to maintain the resilience of the system. In particular, this involves producing predictive models on the variability of renewable energy and quantifying the risk associated with decision making. Last, the aim of here is to reduce negative externalities caused by imperfection in the current market and by historic electricity pricing methods. One solution is to set up platforms to share growing knowledge and data. And lastly, what are the expectations regarding public authorities, research entities, and companies? Public authorities have a major role to play in the choice of the energy mix and the reinforcements of long-term indicators and standards. They need to ensure coordination of investment by the various players in a context of energy efficiency. And I mean various players, in fact, there are more and more, as I explained, more and more entities involved in the flexibility of the system. Public research bodies must foster a more transdisciplinary approach. Coordination with private research should also be thought. Lastly, cooperation between the different stakeholders is essential to boost our country's industrial competitiveness and align technologies, industrial processes, and innovative economic models. So that is that's the end, and I'm ready to answer to any question from the floor.
Merci beaucoup, Olivier, pour cette présentation. Donc, les questions transitent par 24.
Right. So there are the question coming in as, let me just, Olivier, if you can have a look at as well. The first, the two questions, I'll read them in sequence. The first question is, Damien Cortinas, yeah, of course, we read about you. He's in charge of RTA. So, Damya, if you can just open up and speak and make your comments, that would be great.
Yeah, thank you very much. And thank you, Olivier, for a very, very good presentation. So as I have written in the chat, I am in charge of European coordination at RTE. That's for the French participants, it's very well known, but for the others, we are the French transmission system operator. I am very involved in an association that is called ENSOI. ENSOI is an association of all the TSOs of Europe. That we work together on this kind of issues. And what I wanted to say, just a few comments, is that it's true what you said at the beginning, that there has been very, very little prospective looking work on how are we doing in practice the European energy transition. This political goal, everybody agrees, but in how it's going to happen in practice, this is something that has not been much work now, but within TSOs we have tried to do that. And in fact, I have put a link there. We have put together what we call a vision for the future of the power system in 2030. We did a series of webinars last year. It was the common, I would say, knowledge of all TSOs across Europe. And one of the main conclusions is exactly what you are saying, is that the system will not work if we are not able to harness the flexibilities. But I would say there is a small comment that I wanted to make to get your opinion, is that we completely agree, for instance, with what you say, that the new technologies like storage, and also the limits of the big generation as we have it are reaching their limits. But we strongly believe that the future, the solution for this may come from what we call mass flexibilities. For instance, storage is not if you take a storage unit, it may not be cost effective to provide flexibility to the system. But if you take into account that in 10 years time, we are going to have something like 30, maybe 20 to 30 million European electric cars across Europe. And each one of these cars is going to have a battery that is going to be connected to the network every evening. If we are able to develop a model, a market model, where there are aggregators that are able to harness this kind of power, we believe that this is a way for the future, and this could make it happen. But there is a lot of things that needs to be worked, and one of them is the market model for this. But if you just take the numbers, a small electric car is something about 100 kilowatts. 100 kilowatts is not something you can take from a home installation. Is more like a 10 to 15, but even 10 kilowatts for each electric car. If you have something like 10,000, you are starting to reach the kind of flexibility that you could have with a big power plant. And 10,000 or even 100,000 is not that much when you see the number of cars coming. This is just an example. But what do you think about this kind of solution that may come, and that we think that maybe a way for the future?
Thank you for your comment. In fact, I referred in my presentation to vehicle to grid, and you refer to vehicle to grid, which means that the electric vehicle, they are charged in the night, discharged during the day when they travel, but we may also manage the idea is to manage the charging of these vehicles in order to contribute to the flexibility of the system and to bring this power when it is needed. There is, as I said, it's not mature at the time. First, it's necessary when there will be a lot of electric cars, it will have some contribution, but it's not the case for the time being. We need also to ensure that these electric cars will have the possibility to charge and discharge. And for the time being, with the electric cars which are in circulation today, they just can be charged, but not discharged from the vehicle to the grid. And also the charging device has to be adapted, which is not the case for the time being. So, and also this to include this charging discharging device in the car is quite expensive. And we had a presentation from Renault, and for the time being, they don't consider to develop widely this device, which is increasing the cost of the car. We need also to consider the price signal. Is there a price signal for the owner of the car to agree to discharge? And for the time being, there is no price signal. So it's very important to put it in place. And also we need to ensure that there is a business model for RTE, for the electricity system, which is not the case today. And last but not least, this may solve the short-term problem in order to avoid the peak. And it is the case, for example, already the case widely in France with the water heating tanks, around 20 gigawatts, which is huge. But it is, they offer only a short-term storage. They may push the consumption for a few minutes, only a few hours. So it does not solve the problem of long-term or long-term imbalance between supply and demand. Sorry for this long answer, but clearly vehicle to grid is a technology, but for the time being is not completely mature. Perhaps when the electric fleet will be deployed widely with the adequate technologies, both on board and outboard, then this may bring a part of the solution, but only a short-term solution.
For the market model, maybe just a quick comment on that. This is something we are working on, and maybe you are aware of that. Is that there is talk about from the European Union for developing a network code on flexibility that will allow a kind of a level playing field, at least across the European Union, on the market mechanisms that could be put in place in order to, at least from the market side, help develop a business model for this kind of things. But I agree with you that the technological barriers are important. As for the short term, long term, this is something that could be discussed, because it's true that at the beginning it will mostly solve short term issues, but with significant numbers, it could also provide the kind of flexibility we will need in the long term. We are now working, just for information, we are now working we did our work in the 2030 horizon. That is not a very complicated one, because we are next 10 years, more or less, the technology, we are seeing what's going to evolve. But now the big question is the 2050 horizon, is how do you manage a power system with only renewables? And this is something that what we are starting now. And this is the kind of questions you raise, the kind of questions that really will need to be answered. And the only solution will be a way.
You referred to a recent report from the IEA and RTE on what about 100% renewable network in 2050. In fact, personally, I am prepared to make any bet at this horizon, because nobody will be there to tell me that I was wrong. First, we need to be very serious. Second, the conclusion of there are two conclusions on this report. The executive summary, which has been written by RTE, which is quite positive, and so it's possible. And the long report, which was written by the IEA, which is highlighting the fact that it's possible, but there are huge conditions to be met, and this is the objective of the report, which will the following report, which will be released. So we can say it's possible. I would say technology is providing everything or almost everything. But the problem is to ensure that there is a business model and that the stakeholders will invest. We need to ensure that the cost is not too high. You know, direct air capture is possible, but the cost is enormous and totally unsustainable. And also we need to ensure that these measures will be acceptable politically, and we should not ignore, I said before, the 3 dimensions of sustainable development. So in the presentation of this RTE IA report, I was surprised by the difference of tone between the RTE speaker and the IA speakers. And the IA speakers said it's possible, but, and it's very, very difficult. And also there was a final comment by Fatih Birol, the executive director of the IA, who said that in France, you should be crazy to drop nuclear energy because it's a key asset.
I completely agree. Thank you.
Right. The next question, just to stay on the topic of RTA on flexibility, Damia, if you can open up another question for yourself and and Olivier as well. Yeah, I mean, one of the interesting projects that I came across a couple of years back was the whole job of cleaning and coating this reso. And in the US, they have this company, General Cable, which invented a E3X technology and made a business case to clean the whole network. And have you heard of that, or how is because this network was created years back, and they have a pilot of General Cable with the company to install robots and clean this cables across the grid in the Oklahoma pilot, and that's a 30 billion business case. And frankly speaking, I tried to pitch that to EDF with my previous company, and I was thinking that what's your ideas on that?
Yeah, this is a bit off topic, but I may say a few words. These are new technologies for maintenance. For power lines, they are overhead or they are underground, they need maintenance. And one of the maintenance you need to do is to clean them, and particularly the lines who are close to the sea or the lines who are close to pollution centers like towns, like industries, etc. And traditionally, this was being done by hand. You had operators that went up to the line and who just cleaned it. And now a lot of companies are developing drones and robots, ways to do that without human intervention or with humans that are down, not up. And in France, we are also experimenting with several providers. Some of them are small French companies that are going into this market. It's a niche market because the only customers are transmission system operators and or maybe distribution also. Even it's not exactly the same technology. But in any case, one of the main challenges we have now in system operators is how to bring as fast as possible all these new technologies in order to increase the efficiency. Because if you can do it with this kind of robots, you don't need to open the line, and you can do it much quicker. And in the end, this provides more reliability to the system, and maybe you will need less lines in the end. So it's a huge business model, and in Europe we are also doing it, and in France we have some small companies who are going into this market that is a niche one, but it's a very interesting one, and we are helping them.
Sure, got that. Yeah, we will talk that. That's business. Yeah, right. And then, yeah, next question. Michael, May I request yourself kindly, I mean, that's a complex question. I mean, Michael was here, he was speaking the last time. If you can kindly ask that.
Yes, thank you. So, Mr. Appert, so I really appreciate in your presentation the economic issues, that you say that we have to be reasonable on the cost and that it has to be sustainable and accepted by the population. I think that's a very important point. So my question is about sector integration, because the electrical grids, they are not standalone. I mean, we have other grids like the gas grid network. We have in many places and growing rapidly, district heating, district cooling networks. So wouldn't sector integration contribute to the overall balancing of the system? Using legacy systems, as you are aware, we store huge amounts of energy in the gas networks, storage in France, and the examples we have of territories which have reached carbon neutrality, like Copenhagen, for instance, it has been done by a combination of green electricity, renewable district heating, and storage of heat and cold. And in Copenhagen, this example, 98% of the population is connected to renewable district heating and highly efficient district cooling system. So would not this sector integration approach bring value and help to optimize also economically the system?
That's first, I fully support what we said about the necessity to evaluate the cost of technologies. And I refer usually to a methodology used about 10 or 20 years ago popularized by McKinsey. And on a graph, you put each technology from the cheapest technology, the most efficient technologies, to the most expensive technologies. Usually in the companies, you try to evaluate the cost effectiveness of the technologies, and you are choosing in the right order. Unfortunately, in the case of policymakers, they don't evaluate the cost, and so they take crazy decisions without considering the cost effectiveness of these decisions. So you refer to sector integration. In fact, it's a very popular theme, but it's still, in fact, the situation, it depends of the situation of the energy system in each country. You refer to the case of Copenhagen. In fact, carbon neutrality for Copenhagen is possible because there are huge, the building are quite efficient, and also there are district heating and also an important share of renewable energy. I would say it is not the case in every country. In fact, district heating may play a very important role, but district heating is responding to the heating conditions more of the countries in the north. And in fact, district heating has not been developed in the south of Europe because it is not efficient, cost efficient. Another way, there is a theme which to be worked on, which is the storage of heat. And and there are many work which are implemented in order to store heat in summer underground and to recirculate the heat in winter. And also there are quite efficient solutions put in place in the Nordic countries. It is the case in Netherlands or also in Denmark, if I remember well, which is somehow artificial geothermy, geothermal energy, which may have quite an important impact. And also another theme is, in fact, gas storage is playing a very important role in France and more generally in Europe in order to bring flexibility to the global energy system. And so, in fact, the share, I don't remember exactly the figures, but about the share of the energy which can be produced by the storage is representing a very important part of the energy consumed in France. And this brings this seasonal flexibility, which is required for the grid, but which the technologies of electricity storage cannot bring. And so this brings you to the theme, which is popular for the time being, which is to convert some gas storage to hydrogen storage. And so you produce hydrogen in summer, and then you store the hydrogen, and you consume the hydrogen in winter. However, the business model does not exist for the time being. It is possible for the salt storage, the salt caverns, but for the other type of storage of natural gas, the feasibility has not been reached, technical feasibility. Sorry for this long answer.
Thank you for your comments. I think we're largely in agreement. Thank you.
Right. The next question from Iyad, the whole idea of digitalization of this priority. Iyad, I mean, rather than reading your question, long question, maybe you can open up. But Iyad, I think, works with the EDF, right, Iyad?
No, I'm in Publicis Sapient. We are a digital transformation company. We do work with a lot of the energy players in France and in Europe. Good morning, Olivier. You mentioned technology can provide a solution. We need to ensure there's a business model, and we need to ensure stakeholders are willing to invest. And I'm applying this to digitalization. You mentioned that digitization is a research priority. The thing is, flexibility is an ecosystem play, and we need to make sure that all the ecosystem players are involved. We need a holistic approach. So how do we bring digital transformation? How do we bring a system modeling? How do we bring the capacity to forecast when data is scattered across TSO, DSO, and energy suppliers? How do we progress on this front, in your opinion?
That's a good question. Unfortunately, I'm afraid I have no answer. First point, flexibility of the electricity system is not only, it's the responsibility of the TSO, clearly, but it's also now increasingly the responsibility of the DSO, the distribution system operators, because due to the relative decentralization of the electric grid, congestion may happen locally and not only on the highways of the transport network. But as I explained, the solution of flexibility will involve more and more stakeholders. It will involve the producers. It is involving, in fact, the electricity producers and they have to adapt in real time their production to the real demand. This is the case of the thermal power plant, but this will have to be the case also of the renewable energy producers. You referred also in your question to the EV, the electric vehicle. In fact, everybody, every consumer, many consumers are already stakeholders by the heat storage, but in the future, there will be also stakeholders of this flexibility with the EV.
Yeah.
Referring to EV, so there is a consumer, it's necessary to involve the consumer, but also the network. The network has to be developed widely and with the right technology in order to be able to charge and discharge. So the industry also will play an increasing role. And I would say in all these new technologies, somehow there is a digital transformation maybe has to be required. How to convince all these stakeholders to invest in these new technologies. This is what the point I raised about the price signal which has to be put in place in order to ensure that the stakeholders will react according to what the digital technology may provide.
Thank you, Olivier.
If I may make just a quick reaction on that, maybe part of the answer to Iyad is that the fact I mentioned before, there is now work going on about network codes in the European Union on flexibilities. And the TSOs and the ESOs, we are working together now with the European Commission with a green paper that is going to be published by the European Commission after the summer, setting up some ideas about what kind of minimum requirements, a level playing field could be put in place across Europe in order to develop a business model for flexibilities. So this will go in public consultation probably after the summer. And I think for all market actors, this could be a very good opportunity to wade in and to see if there could be some kind of, the main point of this legislation will be how to put in place the mechanisms that will allow for a market to develop on flexibilities and to give the right signals. So we are now working on that. And I think that I really encourage all market actors when this thing will be published by the European Commission probably after the summer to react and to put forward your ideas, because in any case, as system operators, we really want this market to emerge because we will need it, as Olivier has very well explained from the beginning.
So Damien, this will provide guidelines and standards, I guess, so that allows a holistic approach. Yeah,
a holistic approach. The kind of things we are putting there, it's not yet published, but we are working on it, is for instance, in every country, what kind of market mechanisms should be used in order to develop flexibilities, how the data from the individual consumers should be shared across the system, what kind of interoperability you should have. And the idea, as always with the network codes, is to have something that is common to all European Union countries, so that market actors could reach economies of scale as much as possible. And this is the kind of ideas that will go into this network code. I think it goes very strongly into the direction you are pointing.
Thank you, Damien. Thank you, Olivier.
Thank you.
Right. So next question, Girish, please go ahead.
Hey, good morning. Do you hear me?
Yeah.
Hey, thank you, Olivier, for this excellent presentation. So I'm Girish. I work with the GE Grid into HVDC. While you mentioning about the flexibility, you mentioned on the interconnections, and this is where HVDC plays a key role. Now, the problem you clearly highlighted is about the cost. I know my question is very, very pointed. You may not have answered, but what I was seeking is, are there any alternatives? I mean, when hydrogen is coming up, is there any other replacements for HVDC or any other solutions on cost optimization for HVDC as a technology? Technology as such is effective. So that's if any thoughts you have.
Interconnection, it's a very popular theme, and in Brussels you see that there is an excess capacity somewhere and there is a need somewhere else, and you just draw a line. Unfortunately, it's much more difficult to build a line. And personally, I've been involved in a line between France and Spain, Casari-l'Aragon. In 1996, there was an agreement between both governments, French and Spanish, to set up this line. But unfortunately, it has been voted by both parliaments. But unfortunately, there was an opposition, a public opposition in the Pyrenees on the French side. So it has not been possible to build the line. And this line has been opened, and you may, I think that the people of RT may comment on this case. This line has been opened 20 years later in 1916 with an HVDC line, and the cost is 10 times the cost of the first line, which was AC line. So public acceptance is a major issue for building lines. It's the banana concept, build absolutely nothing anywhere near anybody. And the cost. In fact, the high voltage lines are DC in some places close to the cities, for example. But the reduction of the cost of HVDC is very important. And we are raising this issue in our report, saying that it's a very important issue. And I would say the people of the industry in G, for example, have used some solutions.
So indeed, the solutions are only looking at how we implement the technology itself. Today, the major cost is from the cable lines. I think that's given, which is very difficult to come down. But then on the converter stations, that's where we can optimize some cost, but that's not the major ticket item. So major ticket items are the cables, major ticket transmission system, major ticket item is the transformers and the semiconductors. So these are the three elements, and we can reduce down on those costs, but still it's at the margin. It will evolve on how the semiconductors prices or the cable material prices will erode. Beyond that, I mean, today it's well, there will be research. There is research carrying on different topologies, how we can optimize it. But till it is there, it is not there. So we still have those costs on the HVDC. But then the question comes is about the alternatives. We're talking about producing hydrogen in the sea on the wind farm, for instance. Will that reduce the transmission long distance? Study we don't have yet.
Yeah.
Yeah. Okay. I think the answer there is it's it has to. It is there, the high cost.
Sure. And so I understand that there will not be a significant decline. of the cost in the future?
No, it will be steady decline based on what market prices are evolved or will evolve.
Okay.
Thank you.
Right. Next question from Alain. Alain, please go ahead if you're there.
Yeah, so my question is, I'm referring to the introduction by Olivier at the beginning of his presentation, where he explained, you explained, Olivier, that there was this time constant in the power system on the one hand, and that what I understood as well is that these flexibility solutions are really, I would say, limited in terms of their ability to cope for this unbalance in terms of supply and demand. So my question is really, is the catastrophe in France already announced today with the decisions made, like the closure of Fessenheim, for example, or is there still a possibility to avoid future blackouts in France today? And when is it the case that this catastrophe will arrive? I mean, what's the next power plant closure, the next nuclear power plant closure that will be the trigger for the catastrophe, if it's not already the case today?
Yeah. In fact, I used to make a bet to my friends is that there will be a blackout on the 3rd Wednesday of December 2022. It's very precise. Why? It will happen in December because usually it's cold and there are anticyclonic conditions all around Europe. It is the case, and so this the 3rd Wednesday of December is the day where usually the consumption is the highest in France. In fact, the last blackout I experienced was the 3rd December of 1978, which was quite painful. Why 2022? I just explained. In 2022, there will be huge closures of nuclear and coal power plants in Germany. And as you know, we are interconnected. So this will put a pressure on the European grid. In fact, there has been the closure of Fessenheim, but there will be also the closures of some coal power plants. And as you know, for the time being and for quite a long time, the stability of the system is met by the inertia of the power plants, the thermal power plants, both gas, coal, and nuclear. And the reducing share of the power plants, of these dispatchable power plants, is creating a huge challenge for all the countries. In fact, just consider the situation which happened in Texas. You can say that the situation in Europe is different from the situation in Texas. The grid in Texas is in a very bad shape, but it happened it was on the 15th of February. It was very cold, and sometimes it happened that there are very cold weather. And also there was anticyclonic conditions. So the share of renewable in the electricity power supply was perhaps 1 or 2%. You just have to think about it. So perhaps the blackout will not take place on the 3rd Wednesday of December, but perhaps on the 3rd December 2022, but on the 3rd December of January 2023. I think that we need to consider very seriously this issue, and this is a signal which has been launched by the IEA, as I explained, in his report in 2018, which shows the huge increasing demand of flexibility all around the world. And fortunately, in France, we have the opportunity to get the nuclear power plants, which are flexible, but also which are dispatchable. And I just referred to the comments of Fatih Birol at the end of the presentation of the report on 100% renewable in 2050, which should make a mistake in France to drop our nuclear power system. Sorry for this long answer. But in fact, you know, in the working group, we had a discussion with, there were people from RTE, and they were quite reluctant to refer in our report to the possibility of a blackout, because blackout is a nightmare. And it is a nightmare first for RTE. But it's interesting to, just taking into account the case of RTE, I would say 2 years ago, the mode was to know, though there is no problem up to 2035, there is no problem in France. Now, the mode of RTE is more cautious. I refer to the warning which was launched on the 8th of January by RTE. I remind you that in the weather was not too cold on the 8th of January, and the global consumption, the global power was only, I think, 85 gigawatts, where the maximum of the demand was at 100 gigawatts. And there was a warning, a clear warning from RTE that be cautious because something may happen. And why there was this event? It was, the weather was not too cold, but there was a technical problem in Croatia, which split into the European grid. And I would say in the blackouts which happened in London, for example, in UK, was due to a thunderstorm which disconnect CCGT of 1.3 gigawatts, which is not a lot, and at the same time, a wind farm was disconnected. This was sufficient, in fact, to create a blackout, which blocked London for a few hours just in the middle of August.
Yeah, right, got that. So I'm doing the bad job of covering the time. We have a couple of minutes. We take a question from Marie Gerard. She's a Innovation Project Director with NG. Marie, please go ahead, if you're there.
Yes, thank you. Thank you very much. You address the several possibilities to manage flexibilities. And my question is related to these means. You spoke about V2G, for instance, but it's a small small tool in the global possibilities you mentioned. And my question is, what is your opinion on the impact of the future local energy community development in the EU on the flexibility management?
what you mean by local energy community?
Okay. The local energy community.
Follow all the, I don't know all the words in Brussels.
Okay. Actually, there were two directives, the renewable directive and electricity directive in 2018-2019 that were released, allowing the development of local energy community divided into, on one side, citizen energy communities, and on the other side, renewable energy community. And the objective of these communities is in fact to be the most possible autonomous from the grid. It means that thanks to the production of electricity by PV, essentially by PV and the storage with dedicated batteries integrated in these small, small grids, they can try to manage the electricity needs of the participants. The participants into these very small grids. And on the other side, they can also buy this, they can still buy electricity from the grid to ensure the electricity supply to the consumer within this community. And why I do ask you this question is the fact that there is locally possibility of storing electricity and potentially participate in flexibility mechanism into the grid. That's why I would like to have your opinion of this development of local entities.
Yeah, in fact, there is a trend, as I referred, to develop self-consumption.
Yeah.
And at the same time, there is the will for the local authorities to create a local network and to develop self-consumption. But unfortunately, I didn't see any project which aims to be fully autonomous, fully independent from the grid. At the end of the day, the grid will continue to bring safety, to bring security of supply. But this is raising the question I referred at the end of our presentation about the structure of the tariffs. In fact, the insurance brought by the grid to these semi-autonomous entities is related to the power, not to the energies they consume. And the investments which have to be made locally by the DSO, which is completely new. It's a problem at a local level, so it is involving the DSOs. And this investment, in order to ensure the stability of the grid, they have to be financed. And so we need to move to a different split between in our electricity bill between the power and also the energy part. As I said, for the time being, you pay 80% of the energy and 20% on the power. In fact, the share of the power will have to increase significantly because it's the only solution to ensure the possibility to finance the investment at the local level.
Yeah, the grid fees. Yes, the grid fees are expected to increase significantly. Okay. Thank you for your reply.
Merci beaucoup. Nous allons terminer notre petit déjeuner. Merci beaucoup, Olivier. Merci à tous ceux qui ont alimenté cette discussion, à mon avis, de haut niveau. Merci 24 pour la préparation et merci Magali pour avoir organisé tout ça. Je vous souhaite une bonne journée. Donc, prochain petit déjeuner au début du mois de juin. Au revoir.
Merci, au revoir.